I want to show you a couple little quick things. I know you're all working away on these independent vectors, and I just want to clear up a couple things, and then I want to finish the problem that we started with our swimmer yesterday, because it's kind of an interesting turnout. So one of your questions says there's an x value of 5.6 positive. We take that to be to the right, but only because we read left to right. It's not inherently positive. You could say that positive was to the left too, but let's just say this is positive. And then y is negative 7.1. So we say on our vertical y-axis, we're gonna go negative, so that to us is down, but again, that negative is arbitrary. And if you do your second tangent of the opposite of this side is, and I would just say 7.1. I wouldn't say negative 7.1. It works on your phone calculator. I'm not sure if it works on other calculators. And I'll tell you the reason in a second. I would do opposite over adjacent. And that would give about 51.7 degrees. Hold on. And so this angle here is the direction of your resultant vector. Okay, in other words, if your river is going 5.6 meters per second to the right, or say east, and you're swimming downward, what does this direction mean? What does it tell you? It's the magnitude, but what does it mean?
The result.
If this is the river pushing you at 5.6 and you're swimming south, let's say at 7.1, what is this direction? Good, Huram. Good, Huram. So if the river's pushing you and you're swimming down, here's your swimmer, right? And she's swimming downwards. Is she actually going to move straight down?
No.
No, because the river's going to push her, right? So if you were looking down from a helicopter, you would see her getting pushed in exactly this direction. If she can swim at 7.1, is her speed overall going to be 7.1? No, more or less? More. So we can figure that out as well, right? We can use trig or we can use Pythagoras. Does anybody know this number?
9.
9? So if these were meters per second, and this would be 9 meters per second, and our swimmer would move kind of faster than she can swim. Now the question is, if you put this in as a negative, some calculators will give you this as negative 51.7. Eddie, can you flip the door close for us? Thank you. Can I say that this is negative 9?
No.
No. See, Ali's right. You can't say this is negative. You can't even really say this is positive. Why not?
Because the direction is shown by the angle, not like negative.
Yeah, this is partly positive and partly negative. So this is not a binary thing. Right? If this were east, towards the east, and this were south, then this would be 51.7 degrees south of west.
That's what we write down. So.
Yeah, you would say this is 9 meters per second, 51.7 degrees. You start at east and move south, so this is south of east. That's how you might say that. If you're just working in positive and negatives, you just leave it alone. This is just a magnitude. And the direction is given to you by the angle. What would this angle be? 28.3?
38.
Oh yeah, sorry. 80. 38.3 degrees. So just 90 minus this will give you the other angle, right? Okay, I want to show you one other thing. Does that make sense? Okay, hold your hand right here, right in front of your nose. Max, do this. Hold your hand in front of your nose. Now, I'm gonna ask you to close your eyes, and I'm gonna say, if you're really good with this, put your hand up above your head, and if you're like, I don't know any of this stuff, put it down at your chin, okay? And if wherever you feel like you are, in 3, 2, 1, close your eyes and put your hand where it's going to be. Okay, good, thank you. All right, so it's kind of a mix. It's kind of a mix, which is kind of expected. So usually, once you understand this, you're kind of like, okay, yeah, now I can do all of it. If you're still struggling, that's okay. It'll come. You need a little bit of practice, and I can help you out with stuff. One more thing, and then I'll let you have work time, and I'll come around and give you feedback for your labs. But first, I want to finish one problem. Last day we did a problem in class about a swimmer. Do you remember it?
Boat. It was a boat.
Oh, it was a boat. Yeah, it was the 18, right? And you had the boat, if you remember, was traveling straight upstream, right? But the river had a velocity. I can't remember what it was.
I should say it's 8.
It was 11.
11, thank you. So let's say my river has 11 meters per second, and I think it was east, right? Sorry if you can't see that. So the river's going 11 meters per second east, and I think the boat could go 25, is that right?
Yeah.
So if you point the boat straight upstream, where is it actually going to go?
Right.
Yeah, it's gonna be this way, right? Because the 11 of the river is pushing it that way. Okay, well that's fine, and we found this angle too, right? Can't remember what it was.
23.7.
23.7. Oh yeah, and this was 27.3, right? That was the final speed, and this was 23.7 degrees. Now, the next part of this problem
How do we go straight?
is if the boat wants to go straight across, let's say they have some getaway car waiting on the other side. They don't want to end up 150 meters downstream. They want to end up straight across. What are they going to have to do?
23.7 degrees to the west.
I think it's 6.
Who agrees with Zayad?
Kind of.
Just do it reverse,
Yes.
right?
Reverse. That's what I said. For the question similar to this in the worksheet.
You said that, but it's wrong.
Max is right. I think Max is right.
It's not the opposite.
When you can straighten up one of them and
Pause. Pause. This is the resultant of 25 and 11, right? But we want our resultant to be straight across, yes? So let's draw another boat here. Let's say the same boat, and it wants to head straight upstream. Is it going to be able to travel at 25 if the final resultant vector is straight across?
Yeah.
Nope. What do we have to do? Can we point straight across? No, Zoran's shaking his head and he's right. If the river is going to push us, and the boat's going to push us this way, right? So that's not going to get us straight across. We can't point the boat straight across. Where do we have to point the boat? Kira's saying like this, and she's right. We have to point our boat this way, right?
Yeah, so just reverse.
And so if we point the boat that way, and let me
Which one? So
change the drawing of my boat. No, not 27. So this is 25, right? The boat can only go 25. So you're gonna move across the river, but now my resultant vector, is it the hypotenuse? No, because the river is pushing me back at 11, right? So my boat's velocity is my hypotenuse. My resultant vector is now a shorter side of the triangle. Try, right now, jot it down on your paper and try to solve for this VR. If you're watching the video, you can pause it.
Can we use Pythagoras?
Yeah, you can use Pythagoras for this.
Yeah, I was wrong. How was that wrong? Because when you face the boat west, you're hitting more of the left hand, so it's gonna slow you down more.
So let's do it the Pythagoras way here.
Go west, face the current. It's just gonna slow the boat down. The other way, it speeds it up.
I can write it in a calculator if you wanna do it quickly.
So we're gonna say VR is equal to this squared minus that squared. That squared minus 11 squared. So that's 25 squared is 625, right? 625 minus 121 is 504. Square root of 504 would be like, oh, you wrecked it. 22.44. I trust Aveen. So this, my resultant speed is equal to 22 meters per second, or so, approximately. Now, that's less than 25. If the boat can go 25, wouldn't you move across the river at 25? No. Why not? Keelan's going like this, yeah. You're working against the river now, right? The river before, if you just point straight across, the river is adding velocity to you. But if you point against the river, it's kind of like it's working against you now, and you're gonna move slower across the river. You're gonna keep your boat pointed this way, but you're gonna move straight across. Okay. What would happen if the velocity of the river was greater? Yeah, that's right, Soren. It would move even slower. So you'd have to point your boat really hard into the current, and you'd just barely move across. Is there a velocity of the river at which you would not be able to move straight across?
25.
If the river is at 25 and you're at 25, you could point straight into the current, right? And what would happen? The river would be pushing you at 25, and you'd be pushing the river at 25, and you would just sit there. And if you went like this, you'd move across, but you'd get pushed back.
Has that ever happened?
Of course,
When?
happens all the time. So let's say the river was 24, and you could drive 25. What would that look like? You'd have to go really steep into the current, right? And you would move really slowly. You'd be like, and you'd be just barely moving across the river like this. What's the angle here? 26 degrees? Okay. 26.1 degrees. So it's not quite the same angle. You have to angle a little bit more because your boat's velocity is...
I understand.
What do you use for the angle?
Eddie, you understand?
Much better than
Nice.
What do you use for the angle? Like cosine?
There's lots of ways you can find the angle. You can find it with tangent, you can find it with cosine, or you can find it with sine. Any of the trig functions will work. Alright. Why do I flip it? Because we want to move straight across the river. Okay. And so that means our resultant vector has to be straight across. And so I have to add my boat's velocity to the river's velocity. Now this, I'm glad you asked that question because I want to explain, with vectors, you have to add them up. Whether it's velocities or displacements or anything like that, you have to do any vector, you draw them tip to tail. That's how you add them up. And so if we want this to be straight across, that can be our resultant vector, and then we have to add our boat and our river to get that result.
This is ours.
Zaya,
Oh, so what if you're adding like a vector and scalars?
you can't add a vector and a scalar. It doesn't work. You can multiply them, but you can't add. Because you won't have, well, wait a minute, can you? I don't think you can do that. I think that's it. Yes? Yeah, go ahead, Jeff. Okay, that's it for that. You guys can carry on.